Traveling back in time now, this used to be hard. We fly past the Middle Ages. The first human civilization, the ancient ancestors of the first humans, the dinosaurs. The first land animals, the ancient sea creatures, and so on to the very beginning of all time, and there it is. This nebula is our solar system right now. It's just a cloud of multicolored dust made of hydrogen and helium spinning around. This cloud has begun to shrink and become denser. There's a theory that there were supernova explosions near our nebula. Their shock waves squeezed the nebula from different sides until the center of the cloud became too heavy. The enormous weight presses it, and nuclear chain reactions begin at the very center of this cloud. It heats the cloud and makes it glow. Soon it forms into a dense sphere, and that's how our sun is born. It happened about 4.5 billion years ago. Our planet doesn't exist yet. There's only a disk of dust and space debris orbiting the young sun. These pieces of debris are fusing gradually and getting heavier and heavier. Let's look at the very center of this pile of asteroids. The total weight of the debris compresses the central region, so much that a dense metallic core is forming there. The enormous pressure heats the core, and the temperature at the center of the young Earth reaches nearly 10,800 degrees, and there's a liquid core around the solid one. It creates the magnetic field of our planet now. When radiation from the sun and the solar wind reaches Earth, it smashes into a shield in the form of our magnetic field. So far our planet is burning. It looks more like a ball of lava. But it begins to cool down, forming a solid crust. At this point another protoplanet appears on the horizon. It looks more like an asteroid the size of Mars, and this massive piece of debris flies towards us. It hits the young Earth at such an angle that it knocks a part of our planet outward. The debris itself breaks into several pieces and stops in our orbit. After a while all of this debris comes together to form the moon. As a result of this collision, the Earth began rotating too fast. The day now lasts about 5 hours instead of the usual 24, but the moon is heavy enough to slow our planet's rotation with gravity. Now the Earth doesn't look like a hospitable place. The gravitational forces of the moon are penetrating deep into the Earth and causing more volcanic activity. Also, meteorites are constantly falling here, causing frequent explosions on this surface. Now the gas that comes out of the volcanoes forms our atmosphere. The ice that was brought to our planet on meteorites evaporates, the vapor rises and turns into rain. This rainwater falls to the surface, cooling the hot lava and forming the first lakes and rivers. For several 100 million more years Earth resembles the surface of Venus. It's a lifeless place with a bunch of volcanoes, acid rains, and no oxygen debris. The sun wasn't as bright as it is now, plus the sun's rays could barely pass through tons of volcanic dust in the atmosphere. But about 3.5 billion years ago the first life appears here in the form of single-celled organisms that didn't need oxygen. They appeared in the shallow warm parts of the ocean near the shore. These bacteria reigned on Earth for nearly 2 billion years. Throughout the Archean eon they left stromatolites. These are stone pillars at the bottom of shallow warm water. They're the product of simple organisms and bacteria. These bacteria evolved until they learned photosynthesis. Bacteria began to produce oxygen by absorbing the energy of sunlight. At first this oxygen was spent on oxidizing rocks, but then excess oxygen began to fill the atmosphere. Plus at this time the first algae appeared which also produced oxygen. This event is called the Great Oxidation Event. The name which caused almost all living organisms to disappear from the face of the Earth. For simple organisms oxygen was toxic, and the remains of bacteria and microorganisms sank to the bottom of the ocean. Many millions of years later these remains will be recycled, and under the tremendous pressure of water and the Earth's crust, they will turn into oil. The Archean eon ended with this catastrophe about 2.5 billion years ago. At the same time continents were forming on Earth, which would later drift through the world's oceans like puzzles and form a supercontinent, but for now methane and carbon dioxide still make up most of the atmosphere. They cause the greenhouse effect and the rising temperatures on Earth, but the emergence of oxygen stops the greenhouse effect, and the temperature on our planet drops. An ice age, the so-called Uranian glaciation, which lasted from 2.4 to 2.1 billion years ago, begins. Scientists speculate that our planet was almost completely covered in ice at that time, even on the hot equator. A huge change when you consider that 2 billion years ago our planet was like a ball in lava, but now it's like a block of ice. Earth during the Uranian glaciation was more like Jupiter's satellite Europa. There too is a thick crust of ice under which there's a liquid ocean heated by the core. The evolution of the sun saved our planet since its birth 4.5 billion years ago. It's been getting bigger and hotter, so after 300 million years of an ice age, the Earth began to warm up, but almost all life there had been wiped out, and evolution has to start all over again. About 1 billion years ago, all of the continents of our planet were assembled into one hypothesized supercontinent, Rodinia, and all the oceans made up one colossal ocean of Moravia. 750 million years ago that continent broke apart and huge chunks of land began drifting across the planet. Complex plants and multicellular organisms appeared just at this time. Algae, sponges and fungi weren't the only inhabitants of the ocean. This is progenia, they're a kind of worms the size of a human finger. We have remains of these animals that are at least about 550 million years old. 541 million years ago, the Phanerozoic eon began. The main event at that time is the Cambrian explosion. Life began to blossom on Earth, and a great variety of living organisms appeared. Mollusks and echinoderms like starfish and sea urchins appeared. Living organisms evolved having not only an internal, but also an external skeleton like trilobite. Some of these things could reach nearly 3 feet in length. Their protective shell suggests that there were predators in the ocean. A food chain started forming at that time. At the same moment, the drifting continents fused again. This supercontinent has a different shape and is called Pannosia. Later, these continents drifted apart again and began to collide with each other. This led to the formation of mountain ranges. Then the continents met for the last time and formed the giant supercontinent Pangaea about 335 million years ago. Here we can already see the outline of the modern continents of Africa, North and South America, Australia and Eurasia. One of the largest sea creatures ever, the Dinkliosaurus, appeared. Some individuals could be as long as a school bus and weigh as much as a large sub. The land had a hot and humid climate. It encouraged ferns and other plants to grow faster. Some of them could reach the height of a 3-story building, and for the first time in Earth's history some animals leave the ocean and go on lands, such as Alginerbit and Ichthyostica. Anyway, at first they live only on the coast because their skin wasn't adapted to the constant sunlight. In addition, they experience breathing problems. The first animals on land had both gills and lungs, but the lungs were underdeveloped, so they had to return to the water. Millions of years later, these animals evolved into more advanced amphibians. Though they were no bigger than ordinary lizards, they could already live fully on land. But this blossoming of life ended in a new ice age. Glaciers from the poles slowly crept toward the equator. Animals weren't prepared for this, and most of them didn't survive this extinction event. But 290 million years ago, evolution retook hold, and more evolved land animals began to appear. Gradually they increased in size, multiplied, and gave birth to a new species like Scutosaurus and Gorgonopsis. But this period didn't last long either. Only 40 million years later, as a result of unknown events, 95% of all living organisms on Earth ceased to exist. It could have been caused by a giant meteorite or by increased volcanic activity. Also, one hypothesis says it could have been the release of methane from the bottom of the ocean. The Mesozoic era began after this extinction. This is where the dinosaurs as we know them appeared and started a new page in Earth's history.